In this video, we will be reviewing section 7.3, which is solving absolute value equations. So in this absolute value equation, you can see here, I don't have my absolute value isolated. So the first thing I'm going to do, since I've multiplied it by 3, is divide by 3. And I'm going to divide each term by 3 to get that absolute value by itself. So on this side here, 3 divided by 3 is 1, so I'm left with 2a plus 7 equals, on the other side, 3a divided by 3 is a, and 12 divided by 3 is 4. So now I have the absolute value sign isolated. I can look at graphing my absolute value to come up with my piecewise function. So what I'm going to do is I'm going to graph on my calculator 2a plus 7. So I do that and I get this graph, and I'm really focused in on the x-intercept here because that splits it into two pieces, the positive piece and the negative piece, and I will use that to write the piecewise function. So I can say that f of x, my function, is going to be positive. So it's positive here, so when I take the absolute value, it will remain positive. So the function stays as 2x plus 7, and that will happen when x is greater than or equal to negative 3.5. Now I have the negative piece here. In the x-axis, so it will be the opposite. It will be 2x minus 7, and again that will happen when x is less than negative 3.5. So there is my piecewise function, less than negative 3.5. So the next thing that I want to look at before I look at my cases is any implied restrictions. So you can see on this here, when I take the absolute value, it will always be a positive. So I know since it's an equation, the right-hand side must also be positive. So that means that a plus 4 has to be positive or greater than or equal to 0. So subtracting 4 from both sides, I get that a has to be greater than or equal to negative 4. So what I'm going to do is I'm going to put those cases and that restriction together to come up with my solutions. So you can see here I have two cases and I have a restriction. So when I'm solving, I want to just keep this in mind at the very end. So my first case was the positive case, and I'm going to solve that for a. So I'm going to do that by subtracting a from both sides of the equation. So here I have 2a take away a plus 7 equals a minus a is now 0, and that's equal to 4. And then I will subtract 7 from both sides, and I get that a is equal to negative 3. I want to check that in two places. The first place I want to check it in is the subdomain, which says a has to be greater than or equal to negative 3.5, which it is. And I'll check it against my restriction, which is that a has to be greater than or equal to negative 4, so it is also. So it's true in both cases, and I'll check it in a minute. Let's look at case number 2. So case number 2, I'm going to solve for a, and I want my leading coefficient to be positive, so I am going to add 2a to both sides this time. So negative 2a and 2a is 0. I'm left with negative 7 equals a plus 2a is 3a plus 4. I will subtract 4 from both sides, and I get negative 11 is equal to 3a. And to solve for a, I will just divide both sides by 3. So 3 divided by 3 is 1. I get a is equal to negative 11 over 3, which is about negative 3.7. So I'm going to use that and check it again in two places. I'll check it in here, my subdomain, and negative 3.7 is greater than, or sorry, less than negative 3.5, which is good. And then I'll also check it in my restriction here, and it says a has to be greater than or equal to negative 4, which it is. So it looks like I have two potential solutions. So what I want to do now is put it in my graphing calculator. So you can see in my graphing calculator, I've set my equation equal to 0 and put it in y1 right there. And then I do, using my trace function on my calculator, I check my first solution of negative 3. I do trace negative 3, and I get a y value of 0, which means it is the solution. And then again, I use my trace function, and I did trace of negative 11 divided by 3, and it also shows a y value of 0. So I know that is correct as well. So I know that I have two solutions I have a solution of x equal to negative 3 and a solution of x equal to negative 11 over 3 as my final answer.